Hi, my name is SUBRAMANIAM. My metric number is 822A0133. Today I am going to present about data description. First, data is collection of many number of related observation. Each row corruption to question to member data. It lists the value of random number for each variable such as height, weight of an object or value where each value is called a data sheet. The data set may further general algorithm for certain kind of software for testing purpose. Some modern statistical analysis software such as SPSS help us to analyze the chosen data set. We are given a data set of vehicle fuel consumption per 100 km with 393 observation for this assignment, but we choose under 50 out of 393 random data based on the lowest metric number of our group member, and we also choose brand of vehicle and liter per 10 km of vehicle data for the assignment.
Assalamualaikum. My name is NURUL FAREEHA binti Muhammad RIDZUAN and my metric number is 822A0716. I will present about 2.0, that is sampling data and record categorical data. Sampling is a process of selecting a number of individuals or objects for a study in such a way that represents the sample from a target population, while categorical data is a collection of information that is divided into groups. Sample size refers to the number of participants or observations included in a study, and we are used the small last two-digit number of our group member metric number as our sample size of this observation, which is 0.5. The student that have the small number of metric number is Muhammad FARIS bin Hamzah, that is 822A0605.
My name is FARAHARINA BINTI AHMAD. My metric number is 822A0569. I will talk about numerical descriptive measure. First is measure of center tendency. There are three commonly used for this calculation. First is mean. Mean is the sum of the value of each observation in a data set divided by the number of observations. And number two is median. Median is defined as the value that lies in the middle of the data when the data is set, is ordered, or has been rearranged. And number three is mode. Mode is mean the data entry that occurs with the greatest frequency. In the table, there are difference between liter per 100 and brand record. For the mean, liter per 100 is 6.3880 and brand record is 3.53. For median is 6.2500 and brand record is 4. For the mode is 7.69 and brand record is 3. Next is measure of position. For this method, we're gonna use the quartile only. Quartile have three methods, that is first quartile, third quartile, and interquartile range. Interquartile range can be calculated by deducting the first quartile and third quartile. In the table, we can see that first quartile for liter per 100 is 5.4722 and brand record is 3. For third quartile is 6.2500 and brand record is 4. For the interquartile range is 7.1426 and brand record is 5. Next is measure of variation. There are three parameters that are used to quantitate the amount of variation. First is range. Range is the difference between the maximum and minimum data entries. Second is variance. Variance is a measure of variability. It is calculated by taking the average of square deviation from the mean. And third is standard deviation. Standard deviation is the average amount of variability in your data set. It tells you, on average, how far each value lies from the mean. In the table, we can see that range for liter per 100 is 7.85 and brand record is 6. For the variance is 1.789 and brand record is 1.848. And for the standard deviation, liter per 100 is 1.33754 and brand record is 1.359.
For 4.0, that is graphical representation, we use a bar chart and pie chart to represent the liter per 100 and brand. A bar chart displays the distribution of a categorical variables, showing the counts for each category next to each other for easy comparison. The bars are separate categories. Drawing a bar chart graph has several steps. The first step is to determine the data that will be displayed in the bar chart. Be sure to have relevant numerical data that want to include in the graph. Identify the x-axis and y-axis for bar chart graph. The x-axis is used to display liter per 100, which will be represented by the bar, while the y-axis is used to display n or sample. Then define the consistent bar chart across the graph to make comparison easier. Next, pie chart is a circle that is divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. To draw a pie chart to represent brand, several steps are required. The first step is to determine the data that will be represented in the pie chart. Then calculate the total number of n or sample for the brand and relative frequency that will be used in the pie chart. Make sure the total percentage is equal to 100%. Finally, give a label to each brand to identify the percentage it represents. This percentage should be placed near each brand clearly.
Hi, my name is Mohammed FARIS bin Hamzah and my metric number is A22A0605. I will continue the presentation with 5.0 Statistic Analysis using SPSS. SPSS offer data analysis for group identification, numerical outcome, prediction, and descriptive statistics. Additionally, each program offers management tool for direct marketing, graphing, and data processing. So first, we're gonna look at the 5.1 numerical descriptive measure. So this is part 3. The table on the right show you the SPSS calculation, and the table on the left was a table for manual calculation. From the comparison, we got the different standard deviation, variance, minimum and maximum from two variables. Next, this is a bar chart. The x-axis is used to display a liter per 100, which will be represented by the bar, while the y-axis is used to display n sample. Then define the consistent bar chart across the graph to make a comparison easier. From the bar chart, we can see that the lowest liter per 100 is at the rate of 1, while the highest liter per 100 is the rate of 20. This both result SPSS and the manual result is same. Next, pie chart. A pie chart is a circle that is divided into sectors that represent categories. The area of each sector is proportional to the frequencies of each category. To draw a pie chart to represent the brand, qualitative variable data. From the pie chart, from the both result, SPSS and manual, we can see that the BMW brand has the highest relative frequency of 29%, while the Citroen brand has a lowest relative frequency of 1%. At the 5.2 hypothesis testing, process of testing a hypothesis relies on certain sample data and probability theory to determine if it can be rejected or not. In this section, we are measuring the reasonableness of the hypothesis and determining whether it should be rejected or not using independent sample t-test and ANOVA. For make a hypothesis testing, we use the five main steps. The first step is state the null hypothesis and the alternative hypothesis. Step 2, state the level of significance, which is A equals to 0.05, and step 3 is SPSS output. Step 4, decision rules. Reject hash none if P was small than 0.05. And the step 5, decision. Reject hash none because P equals 0.00. P was under the 0.05, under the critical value. Next table shows the ANOVA for all variables. The table displays the result of a study that compares 5 variables. A significant level, SIG, indicates the likelihood that the observed result occur by chance, and it's considered statistically significant if the difference is smaller than 0.05 at the significant level. So this is 5.3 correlation analysis. Correlation analysis is used to measure the strength and direction of the relationship between two variables. It helps to determine if there is positive or negative correlation between two variables and how strong that correlation is. The table shows that there is a strong negative correlations between liter per 100 and brand record. This means that as liter per 100 increase, brand record tend to decrease, and vice versa. The correlation is statistically significant, indicating that it's unlikely to have occurred by chance. In the scatter plot matrix, plot liter per 100 against brand record. There is a strong negative correlations between liter per 100 and brand record. So next we go to 5.4 confidence interval. So the table of confidence interval 95%. The table shows descriptive data for liter per 100 and brand record. Liter per 100 has a mean of 6.39 and a standard deviation of 0.109 and a range of 3 to 11. Brand record has a mean of 3.53 and a standard deviation of 0.111 and a range of 1 to 7. Both variables have similar interquartile range of 2. And confidence interval for 99%, the table shows descriptive data for liter per 100 and brand record. Liter per 100 have a mean of 6.39 and a standard deviation of 0.109 and a range of 3 to 11. Brand record has a mean of 3.53 and standard deviation of 0.111 and range of 1 to 7. The 99 confidence interval for the mean of both variables are given. The median liter per 106.36 and the median for brand record is 4. The interquartile range is 2 for both variables. Next, we go to 5.5 prediction modeling. We need to construct a regression model which is incorporate the variable of interest following the general form of multiple linear regression. So multiple linear regression is a statistical technique that let us use multiple variables to predict a dependent variable and determine the unique contribute of each independent variable. The equation is y equals b0 plus b1 times 1 plus b2 times 2. Y is the value of the independent variable. b0 and b1 are parameter, times 1 and times 2 are known constant. So the test of normality, the table test of normality shows that the Shapiro-Walk test of normalities on the residual give a p-value of 0.21, which is more than 0.05. Thus, the assumption of normality of the liter per 100 is moderate to strong correlation. And for model summary, the r-square value is 0.781, which is mean 78.1% of variation in model 1 can be explained by brand record. And for coefficient tables, we got the equations that 9.461 plus 0.898 times 1 plus 0.870 times 2.
My name is AIYUB bin Murad, A22A 0435. So I will continue the presentation for the conclusion. We use a data set of car fuel usage per 100 km with the following variables, which is liter per 100 km, travel distance, cylinder, horsepower, weight and brand. Our team decide to choose the brand and liter per 100 km as variables. We found that the values are different between the manually calculated and the SPSS system, and the distributions shape may be classified into two ways, symmetric and non-symmetric. SPSS is unable to read the data accurately, and the mean, median, and mode produce varying results. It emphasizes the use of graphs to think about model and pattern. So that's all from us from group 12. Thank you.